Hey everyone, today I'll be doing the mechanics quiz for the course practice of sections 1.1 to 1.7 in the mechanics book. The other course practice quiz is about vectors, and this one's about one-dimensional motion. So let's get started. Question 1. Which of the following is true about speed and velocity? That apply. Instantaneous velocity is instantaneous speed in a specified direction. That's correct. Because in a one-dimensional line, right, say you're moving with 5 meters per second. Okay, so 5 meters per second, right? Now, if you were talking about your speed, you just say I'm moving with 5 meters per second. At this point, let's call this t0. Okay. However, when I say velocity, I'm specifying my direction if it's instantaneous. Okay. Second point, instantaneous speed can be lower than the average speed in a given one-dimensional journey. That's correct, because you can plot a VT graph. Okay, you can plot a VT graph that goes, for example, like this. Okay, here, the average, like this, look, this tangent would be, or the secant here, would be very steep, right? Like the average journey. However, if the instantaneous speed, for example here, the instantaneous speed at this point, the tangent is almost flat, right? It's going something like this. So it's almost flat. Which, by your observation, which can you see is steeper? This one or this one? Obviously, the tangent here I plotted incorrectly. Like if I were to plot it, would be something like this. It's basically flat. Okay, so obviously this one's steeper, and this is actually measuring the average, because as you can see here, it's starting at this final point and at this initial point, and we call this line a secant. Okay, and then this line here is the tangent or the tangent. Okay, now, so these two are correct. The instantaneous speed always equals the magnitude of instantaneous velocity. As we said, instantaneous velocity is just instantaneous speed specified with a specified direction. So their magnitudes will always be equal. If, for example, I have 5 meters per second and negative 5 meters per second, right? This, and it's describing the motion of the same object. This c would be its speed, and this c would be its velocity. Now, the velocity can be divided into two components, right? Its magnitude and its direction. What gives its direction? How do I know its direction? By the positive or negative sign. So let's say this direction is the positive direction. So what this negative sign is telling me is it's going this direction. This is the motion of particle, let's call it the particle A. So this is the motion, right? But as you can see here, their magnitude, the 5 meters per second is equal to the speed, which is also 5 meters per second. Okay, question 2. Students are describing the change of position of a hiker. Choose the correct answers. The change in the position described as the hiker moved to 10 kilometers is a scalar quantity. Yes, this is true, because a scalar quantity only has a magnitude. That's it. Okay, no direction. A vector quantity has a magnitude and a direction. Okay, so the change in position described as the hiker moved to 10 kilometers is an example of a scalar quantity. Yes, scalar quantity, because here we only have 10 kilometers. Whereas in part B, you can see it says the hiker moved through 10 kilometers due east. So this part here is the magnitude, and this part here is the direction. Okay, and that is the vector quantity. Question 3. This one's very easy. So they told us that the person initially moves from point A to point B and then back to point C. Okay, so that says motion. Now, the distance traveled will be from point A to point B and then from point B to point C, right? So what's the difference between point A and point B? 15 meters, right? What's the difference between point B and point C? This here is 9 meters, so this is 9. 15 minus 9 is 6 meters. So the distance is going to be 15 meters plus 6 meters, which gives me 21 meters. That's my correct answer. The displacement For the displacement, which is denoted by delta x, okay, the displacement is just the final point or final position minus the initial position. Okay, so here we started off at 0, so this is our initial position, and our final position is at C, which is 9 meters. So final minus initial, 9 minus 0 equals 9, so delta x, which is our displacement, is 9 meters, and that is how you calculate these two quantities. Question 4. Okay, the diagram below shows the path ABC followed by a girl walking her dog in the park for 0.6 hours. The diagram is not scale. Okay, so ABC. So she took this path, A to B and then B to C. Now, keep in mind, this doesn't mean that she did this. She went from A to B, then B to C, and then C to A. No, she didn't do the full triangle. They included this measure for A to confuse you and B for a specific reason. So let's start with A. They want the average speed. The average speed, you should know, is distance over time. So she walks across ABC, so A to B and then B to C. We have the distance. The distance is 1 plus 2.8. So our distance is 3.8. Over the time is 0.6 hours, as given here. Gives me on a calculator, so 3.8 over 0.6, 6.2 meter per second. Or kilometers an hour, sorry, same thing. Not the same thing, but it's like whatever, kilometers an hour. Okay, now the average velocity. The average velocity is denoted by V average. Sorry, let me rewrite it. V average equals to delta x over t, delta t. Okay, now the displacement is just gonna be again final position minus initial position. Our final position was point C, this is final, and our initial was point A, this is the initial. So we need the distance between point A and point C, which is given to us as 3 kilometers. So the displacement is going to be 3 kilometers. V average equals to, by the way, you can denote it V av and V average, it's the same thing. So 3 over 0.6, which gives me her velocity to be 3 over 0.6, 5 kilometers an hour. Okay, now you might have noticed I didn't do the second part of each of the second answer of each of the parts, and now I will get to them. So the average speed is a scalar quantity. Okay, speed is a scalar quantity, means it has no direction. So when it says and has no direction, because it's a scalar, so this is correct. Now velocity is a vector, so you have the magnitude and its direction. Now this tends to be in the direction of the displacement, which as you can see is north, so it's directed due north. That's the direction of our velocity. Question 5. Okay, here where people will get confused is they won't see, they'll skim the question, they'll skim reading it, and they won't see that this is just asking for the magnitude. They think it's asking for the full velocity. Why is this an important distinction? Because you can see that this is going downwards, right? This is a straight line, okay, which first of all means that the velocity in a straight line, by the way, just so you know, the velocity in a straight line is just the slope or the gradient of that line. So V equals m. Okay, that's the average velocity. And it's the instantaneous velocity, by the way. You can it's even the instantaneous velocity equals to the gradient or the slope m, because it's a straight line, right? So any point on this line will have the same slope, meaning it will have the same average velocity, same instantaneous velocity, right? So now, where do they want? They want at t equals 2 seconds. So t equals 2 seconds, it's this here. So this is their point. Now, we find the slope of this line, because as I said, the average velocity is the same thing as the instantaneous velocity. So we can do this point minus this point. Or actually, because I don't know if this is t equals 0, it is t equals 0, so we'll take it. Now, the V average which is the gradient or the slope, is equal to 2 minus 0 is just 2. 20 minus 15 or 15 minus 20. 15 minus 20 so we can get the full velocity. Gives me 15 minus 20 over 2, negative 5 over 2, which is negative 2.5 meters per second. Okay, so now we found our slope. So that means at any point, so even at t equals 0, the velocity is negative 2.5. Here it's also negative 2.5. Here it's also negative 2.5. Here too, and this here too. Well, okay. Now that we know this, right? Again, it's at any point. It's the average is the same thing as the instantaneous in this case. So they want the magnitude, not the full thing. It's just its magnitude. So the magnitude is the number we got without the direction. So without the positive or the negative sign. Okay, without like explicitly writing it. So our full velocity is negative 2.5 meters per second, right? So that means the magnitude is just going to be 2.5 meters per second. And that's the answer. Question 6. A car initially moving at 30 meters per second decelerates to 5 meters per second in 3.8 seconds. What is the acceleration of the car? Okay, acceleration. Here they want the average acceleration. So A average is equal to V2 minus V1 over T2 minus T1, which can be simplified to delta V over delta T. Okay, so now that we know this, the average acceleration is going to equal to 5 minus 30, because it's V2, this is V2 and this is V1, minus T2 minus T1. It says that the change in time was 3.8 seconds, so that's what we're going to use. So negative 25 over 3.8 gives me negative 6.57, which rounds to negative 6.6 meters per second squared, because it's acceleration, and that's the answer. Question 7. Okay, so the time interval during which the toy car is at rest. So at rest means there is no change in position. So this is constant, right? This xc will be constant. So that means a flat line, an xt graph. If it was vt, then it would be where the tangent is flat. So here, for example, if this was a vt graph, okay, it would be this point here, because the tangent to it is flat. Now, so they want the point which is rest, which you can easily infer that it is this part here, right? Now the hard part is finding what point is this, which isn't even hard at all. Look, you can go 1, 2, 3, 4, 5. So we reached 5, which means that this goes up by 1. So this is 1, 2, 3. So this here is 3, and the time interval it is at rest is 0 seconds, 3 seconds. Okay. The farthest point from the origin. So you want to see where the distance between the origin is the highest, right? So as you can see, it's obviously this point, right? Because look how big the difference is between here and here. Look, it's a very big difference, right? Obviously, it's not going to be here because that line's way smaller. This line's way smaller. So it is at this point here. And you can even tell by eye level. Now, how much does this go up by? So you can go 2, 4, 6, 8, 10. So this goes up by 2. And oh wait, also we don't even need to do that because it just told us this is 10 meters anyway. So the farthest point is 10 meters. The net displacement is the initial point, which is here. As you can see, this is where the point started, right? And the final point, which is here. Now, this is where we found how much this goes by is useful. So this part's 10, right? Now subtract 2, 8, subtract 2 again, 6. So this part here is 6. Now, 10 minus 6, this is delta x. Because that's what they want, net displacement. 10 minus 6, which equals to 4 meters. That's my final answer. Why am I on my calendar? Okay, the total distance traveled by the car. Now this is very easy. Look, as you can see here, this part is 0 meters because the car stayed at rest here. And we know that this part here was 6 and this part here is 0. So from here to here, it's going to be 6 meters. And now negative 2, negative 4. So this part is negative 4. So it traveled 4 meters. And here it went back up to the origin. So it also traveled 4 meters again. And it went up 10 meters. So we're going to add up all of this. 0 plus 6 plus 4 plus 4 plus 10. This will give me, so 0 plus 6 plus 4 plus 4 plus 10, 24. And 24 is my answer. Now, the toy car is at the origin, so when it crosses the x-axis, at this point here and at this point here, this is 6 seconds, and this is 11, 12, 13 seconds. Okay, so that's at 6 seconds and at 13 seconds. Now, question 8. So it shows that these three people ran a race. Which runner won the race? Obviously the one that reached the 100 meters in the shortest time, which is Albert. Okay, and which runner stopped for a rest? When they say stopped for a rest, that means you have a flat line because they're at rest, right? There's no motion, which is this. And if you trace the graph, you will see it belongs to Charlie. So that's who did it, who stopped for a rest, Charlie. Question 9. What is the net displacement of the skier from t equals 0 to t equals 3? So net displacement, I'm only concerned about the initial point or with relative to what they give me, right? So t equals 0 is here and t equals 3 is here, right? So how much did he travel from here to here? 40, 100, 140 meters, right? And what's his direction? He's facing right. So he's facing this direction, so to the right. That's the answer. Question 10. What's the average velocity in the time interval 1 second, 3 seconds? So 1 second and 3 seconds. See. So we're going to have to draw the secant between the two lines and find the slope of this secant. So what we're going to do is V average equals to since these 2 points both belong to the same line on the secant, you can use them to find your slope. So the time, first I'm going to start with it. It's going to be 3 minus 1. Okay, and then it's going to be the distance here is 6 and the distance here is 1. So 6 minus 1. V average is equal to 5 over 2, which is 2.5. I don't need to use the calculator. 2.5 meters per second. Question 11. The net displacement of the toy car and the distance covered by it are equal along the path. Okay, so the displacement and the distance means that it only went in one direction, right? If they're equal, okay? Because if it went back, like for example, you have this, then you have this. You're gonna have the displacement to be this point and this point, but you're gonna have the distance to be here and then all the way there, right? So that means when the displacement and the distance are equal, it only moved in one direction, okay? Which in our case is PQRT, right? It moved only in one direction. It went from P to Q, then Q to R, then R to T, right? It only went one direction and did not go back at all. So that's when they are equal. Now, the track moves along, or the car moves along the track PQRQ. So PQ, QR, then RQ, right? As you can see here, the distance and the displacement are not equal because the distance is the displacement is only from P to Q, which is 70 meters. That's my displacement, right? Because it's final minus initial. And my distance, and by the way, that's the answer for the first part. My distance is actually gonna be PQ plus QR plus RQ. So PQ is 70, QR is 110, then QR is just the same thing, so it's 110. Add them all up, you get 70 plus 220, which is 290. And that's my final answer, or 290 centimeters. As you can see here, since the car moved back, so it was moving in one direction, then it started moving in the other, the displacement and the distance are not equal. Now, that's the end of that question. Question 12. A toy car is constrained to move along the straight track PQRT. Assume that the car can change direction very quickly, blah, blah, blah. Okay. The average speed of the toy car as it moves along the path PQRTRQ. So, I don't need the diagram above, but if you want me to draw it, I can. Let's just use it for reference. So, this is P, this is T, this is Q, and this is R. Okay, so PQ is 10 meters. So PQ in this direction is 10 meters. QR is 20 meters. Okay, RT is 40 meters. And now TR is 40 meters. Okay, it's the same thing, but it's the same distance because again it's RT and TR. It's the same exact thing, but they took different times to cover it. Okay, so it moves along the path PQR TRQ. So PQR, then it moved to T, then RQ. So it stopped here, right? So it moved all the way to here and then all the way back here. Let me. I won't use this anymore because it will get messy. So they want the average speed. The average speed is distance over time. Now, the distance covered is going to be PQ plus RT plus TR plus RQ. So, PQ is going to be 10 plus QR 20 plus RT, which is 40. And then TR is just going to be 40 again, plus RQ is 20. So adding all of this up would give me 10 plus 20 plus 40 plus 40 plus 20, 130 meters. Okay, now let's find the time it took. So from P to Q, it's going to be 5 seconds. So T is equal to 5 plus, then Q to R, it's 10 plus, RT is 18 plus, TR is 12 plus, RQ is 10. So it's going to be 5 plus 10 plus 18 plus 12 plus 10, which gives me T equals 55. Now, 130 over 55 gives me 2.36 meters per second. That's the speed. So is equal to 130 over 55, which is 2.36 meters per second. And that's the final answer. Now, the average velocity. The average velocity is the displacement, okay, over the time, right? But the time is the same, right? The time did not change because you took all that time to cover this distance. However, the displacement changed, right? Because the displacement is just PQ. So PQ is 10 over all the time it took. So it moved from all the time. We're counting P to Q, then Q to R, then T to R, then R to Q again. So we're counting the same time, which is 55 seconds. So the average velocity is going to be 10 over 55, which is 0.18 meters per second. Okay, now, in which segment is the instantaneous speed the greatest? So, the instantaneous speed, you're just gonna have to find the distance over the time. So here, this is 2, this is 2, this is 2.2, I believe. This is gonna be somewhere, I think 3.3, something like that. Let me check. 3.3. And this here is going to be 2. So it's obviously TR, because as you can see, TR has 3.3 meters per second. And that's the greatest speed for instantaneous speed. So it is TR. Question 13. A toy train is constrained to move along the straight track PQRT. So drag and drop the answers. Okay. So they want to compare the distances. And you can have the same rank. Okay. So the distance traveled, obviously the more letters the better, right? And as you can look at the distance, so PQR TRQ. I'm going in the order that is the answer in PQR TRQ. So PQ is 80, then QR is 80, then RT is 120, so 80 plus 80 plus 120. Then it went back, so another 120, and then it went back to Q. So it is 80 plus 80 plus 120 plus 120 plus 80. Okay, so the distance traveled here is 480 meters. Now, PQR TR. So PQR. So it went from P to Q, then Q to R, then R to T, then back to R. So adding all of these up is 80 plus 80 plus 120 plus 120, which is 400. Okay, then PQR. PQR is just gonna be from P to Q, then Q to R, which is 80 plus 80, which is 160 meters. And then PQP is just gonna be P to Q, then Q to P, which is 80 plus 80, which is 160 meters also. So as you can see, this is the greatest, this is the second greatest, and these two are the same rank. Now, the displacement will tell you a very different story. The displacement, okay, we'll start off with the PQR TRQ. Okay, the displacement is just gonna be, we're skipping all of this in the middle. It's just gonna be P to Q, right? And P to Q, okay, sorry, P to Q is just 80 meters. This is just 80 meters. Now, PQP, okay, I'm going from bottom to top. This is 80 meters. PQP, so we're skipping the middle part. It's just from P then to P again. So this is gonna be 0, right? Because you didn't move. Now, PQR, it's gonna be from P to R. Now, P to R I think they were 160 centimeters apart. Yes, they were 160 centimeters apart. So, here, well, let's go back and rewrite our list. It is, this is gonna be P to Q, which is 80. This is gonna be 0. This is gonna be 160. And this is gonna be from P to R again. Like, this is the same thing as this. So this is also gonna be 160, meaning that these two are the greatest. This is the second greatest, and this is the last. Okay, now, the speed at which the train can move along the track is 30 centimeters per second. Assume it can change the direction of motion very quickly. The engine of the train is turned on for 1 minute. Okay, so 1 minute, we're gonna take this as 60 seconds. Okay, now, because here we have 30 centimeters per second, that's why. Look, as you can see, it says the speed is 30 centimeters per second. So let's see the greatest distance it can travel, right? Let's find this, then I can answer this. Now, distance is average speed multiplied by the time. So it's gonna be 30 times 60, which is 1,800 meters or centimeters. Okay, and that's my answer to this part. Now, as you can see here, the greatest distance it can travel is 1,800 centimeters, right? 1,800 is the greatest distance. However, the difference from P to T, which is the greatest displacement it can possibly cover, right? Because this is from one end of the track till the other end. Okay, so this is the greatest distance it can cover. Add them all up, 80 plus 80 plus 120. 160 plus 120 gives you 280 centimeters. Right? Now, 1,800 centimeters is obviously greater than 280 centimeters, right? So that means that it can actually cover this displacement and back and again and back. Like, I think maybe, let's calculate it. It can cover it, oh, sorry, this was 180. 1,800, now I fixed it. It can cover it 6 times. It can cover this distance here 6 times, and then it'll have some distance to go back. So the displacement, the greatest displacement it can cover is obviously this whole thing, right? Because it can go all the way here and then stop, right? It can stop here, خلاص. يعني, because that's the greatest displacement covered. Done. So that's why the greatest displacement is just all of these added up. Question 14. Now, the motion of the glider is uniform. How do we find this? Okay, this is just useless information. I don't care about it. I find how much this is increasing by. I find how much each is increasing by. So this is increasing by 1, this is increasing by 1, this is increasing by 1, this is increasing by 1. You get it, the time keeps increasing by 1. This is increasing by 3, this is increasing by 3, this is increasing by 3. This starts increasing by 4, then 5, then 9. As you can see here, right, the time is always uniform. Okay, so that's fine. We don't have to worry about that. But until this point, as you can see here, these will all have the same slope, right? It's gonna be, as you can see, they're increasing by the same amount, right? So the slope is gonna be 3. Okay, so knowing this information, now that we know this, you can see which part is obviously uniform, right? It's gonna be this here, because as you can see, it's 3, 3, 3, and 1, 1, 1. Not like the second part, 4, 5, 9, 1, 1, 1. No, this is uniform. So it's gonna be the interval of where does it start being 3, 0, and then where does it stop being 3 at 3 seconds. So the interval is 0 seconds, 3 seconds. Okay, now moving on, the speed of the glider identified in part A. Okay, as we said, it's uniform in this part, right? So if we were to graph it on a VT graph, let me just do it for your reference, yani. This is V, this is T. It is like this. It starts off as a straight line until T equals 3. So until 3 seconds. Okay, and then it starts increasing at a weird rate. So this would be something like what our graph would look like. Okay, now as you can see here, remember when you have a straight line, the average velocity is equal to the average the instantaneous velocity, which is equal to the slope of the graph at this point, right? So it's gonna be the slope is gonna be 8 minus 5. Let's take these 2 points, 8 and 5. 8 minus 5 over 2 minus 1, which gives me 3 over 1, which is just 3 meters per second. And that's our final answer. Question 15. Okay. Okay, the graph below shows the position of a robot. The average velocity of the robot over 10 seconds of motion is, okay, now the average velocity is the displacement, right, over the time. So the time is going to be 10, right? And the displacement, as you can see here, where did we stop? So keep on tracing this line. Stopped here. So this is, as you can see, it goes by 0.5 each time. So this is going to be, for example, 0.5, 1, 1.5, 2, 2.5, 3, 3.54. Okay, so it goes up by 0.5. Now here, negative 0.5, negative 1, negative 1.5, negative 2, negative 2.5, negative 3. So this is negative 3 here. Okay. Now that we know this, we can find the displacement. The displacement is obviously going to be negative 3, right? Because it started off at 0. Remember, displacement's final minus initial. Negative 3 minus 0 is just going to be negative 3. So it's going to be negative 3 over 10, which is negative 0.3 meters per second. And that's my value for the average velocity. Okay. The average speed is the distance over the time. So it's going to be over 10 seconds again. So now we're going to find the distance covered. So this part here is 6 meters covered, right? Because it went from 0 to 6. Now, the change here, as you can see, it's 6. It started off at 6 and it ended at 6. So there's no change in distance. It's going to be 0 meters and it's a flat line. Now, here it started off at 6 and then went to negative 3. So, obviously, that's a change of 9 meters, right? Because you know, you start off at 6 and then you end at negative 3. Negative 3, so to find the distance, okay, between 2 points, it's the absolute value of the final point minus the initial point. So the distance is absolute value of minus 3 minus 6, right? Because it's final minus initial. The final was negative 3 and the initial was 6. So minus 3 minus 6. The distance is negative 9 and absolute value is 9. And that's the change in the distance between these 2 points here and here. Anyway, extra info. Also, I didn't need to go through all of that. Yep, I think you can already get it why. And you start off at 6, you end off at negative 3. How much is that? That's 9 meters traveled. So 6 plus 9 is 15. 15 over 10 is 1.5 meters per second. And that's why that's your average speed. Okay. Now, average speed, so you have to identify the time intervals where the average speed is equal to the average velocity and the average speed is equal to greater than the average velocity and the average velocity is greater than the average speed. Okay, now average speed equals average velocity. Let's look at the intervals they give us, 2,6 and 1,8. So we start off at 2 seconds, end off at 6, and then 1 second, end off at 8. Okay, so let's calculate the velocity and the speed for both of them. So let's start 2 and 6. So 2 is here, 6 is here, right? So the speed, okay, is distance over time. The distance traveled is from 4 to 6, which is 2. The time taken is going to be 4, so 0.5 meters per second. Right, and then the velocity is going to be the displacement, so the final minus the initial point. It's going to be 6 minus 4 again, because as you can see, you ended at 6 meters and started off at 4, which is the change in 2 meters, over 4, which is 0.5 meters per second. So the interval where the velocity equals the speed is 2,6. Okay, now let's find it for 1,8. 1,8 is, sorry, here and here. Okay, the velocity, the speed is distance over time. So the speed is going to be this part here covered, which is from 2 to 6, which is 4 meters. Okay, and here it's going to be 0 meters, obviously you know why. And then it's going to be from 6 to, what is this? So this is going to be, this is 4, 3.5, 3. So this is going to be from 6 to 3, which is 3 meters. Okay, so the distance traveled is 7 meters over 10 seconds, so 0.10 or 0.7, sorry, 0.7 meters per second. Now the velocity, okay, the velocity is just, we're going to ignore all of this distance traveled and we're going to focus on the final and the initial. Now, the final is 3, the initial is 2. So how much is that? 3 minus 2 is 1. 1 over 10, which is 0.1. As you can see, at 1,8, the speed is greater than the velocity, and that's what you can find here. Okay. Now, the average velocity greater than the average speed will never happen in this interval because, you know, the average speed is, and you can easily infer why. بس even then أصلا يعني you identified that these two are already taken, leaving you with this as the only choice, right? So that by the process of elimination this goes to here. But obviously you can find it mathematically, بس يعني it's a lot of time or there's no point in doing it because خلاص يعني it's very clearly average velocity is equal to average speed in this interval, average speed is greater than average velocity in this interval, and they only gave you these two intervals. If they gave you a third interval, then find the average velocity, find the average speed, compare the two, and then you'll see that if there is an interval or not. Okay, question 16. A simplified assumption used to analyze complex situations is known as a model. We know this last year, and it's very easy to recall. The location of an object on an axis at any instance with respect to the origin zone is its position. Okay, here's the difference. So you have position and you have displacement. I'll refer to displacement as delta x because I'm not going to write it. Now, position is relative to the origin, so relative to O. Now, the displacement is relative to its initial position. Okay, so it's basically final position minus the initial position. Okay, and these are your two, this is the two difference between position and displacement. Okay, now, average velocity. Average velocity, you know, is delta x over delta t, which is displacement over time. Average speed, you know, is distance over time. A model is a simplified assumption, and the position is location with respect to origin. Okay, this is very easy. Question 19. This question, I believe, is repeated, no? It is repeated, I'm pretty sure. But just in case, we'll solve it again. So, the time interval during which the torque car is at rest. So, torque car at rest, as you can see, it's from 0 to 3, right? Because the line is flat and it's a xt graph. So, this line is flat, which means that the motion, the particle did not change its position, which means it's at rest. Okay, the farthest point, the origin, from the origin, it's 10 meters here. Right, you can see it's the highest point on the graph relative to the origin, right? أصلا يعني here this is only, I believe this goes up by 1, 2, 3, 4, 5. So, yeah, 2, 4, 6, 8, 10. This point is 6. And that's the second highest point it reaches. So as you can see, يعني obviously 10 meters is way, way higher than 6 meters. So this is the highest point reached on the, from the origin. Okay, the net displacement is going to be final minus initial. As we said, this is 6 and this is 10. What's 10 minus 6? 4 meters. And that's my displacement. Okay, the total distance traveled. So this part here is 0. This part here is 6. Because remember, this is 6, this is 0. So 6 and 0 is 6. Now, this part here is 4 meters. Again, we're not counting the signs. This part here is also 4 meters. Because again, this is negative 2, this is negative 4. Okay, and then this part here is 10 meters. Add them all up. 6 plus 4 is 10, 10 plus 4 is 14, 4 plus 10, or 14 plus 10 is 24. Moving on. The toy car is at the origin. So when is it at the origin? When it crosses this axis here. When do we have crossing intersection? It's here, which is at 6 seconds, and here, which is at 13 seconds. Okay, moving on. By the way, regarding repeated questions, questions 29 and 30 are also repeated. So I'm gonna skip them. I believe this is one of the questions that were repeated in questions 30 and 31. Sorry, not 29 and 30. Questions 30 and 31 are repeated. Okay. So I'm not gonna solve them. It's repeated in the same exact quiz. This quiz, I explained it, I think 20 minutes ago. The questions that were repeated, if not way earlier or like way later. So now the net displacement. So the net displacement is the final minus the initial. The initial is 0. Because that's at the origin. The final is at, how much does this go by? 1, 2, 3, 4, 5. So 4, 6. So this is by 4. This is 4, 8, 12, 16. So this is 4 meters here. 4 minus 0 is 4 meters displacement. Okay. The total distance traveled by the particle over the course of 30 seconds. Okay, so here, from here to here, it's 20. Right? So from here to here, it's 20 meters. Then from here to here, it's 20 meters. From here to here, it's 8 meters. Because remember, this is negative 4, negative 8. This is 0 meters. And then from here to here, it's 8 meters again. And then this is 4 meters. Okay, so adding it all up, 20 plus 20, 40, 48. 48 plus 8 is 56. 56 plus 4 is 60. 60 meters. Distance is for 60 meters. That's your final answer. The average velocity, okay, interval 0 and 14 for speed, and they want speed and velocity at 0, 14. So this is 12, 14, 14 is here. This is 14 seconds. The x here is -8, okay, and then they want it from here. Now, the velocity is the delta x, so -8 minus 0 is -8 over 14 minus 0 is 14, so this is your velocity. It's gonna be equal to -8 over 14, -0.57 meters per second. Okay, now the speed tells you a different story. So you started off here, you're ending here. So you traveled 20 meters here, you traveled 20 meters here, you traveled 8 meters here. So 48 over 14, this is your speed. Right, because 20 plus 20 is 40, 40 plus 8 is 48. So speed is equal to 48 over 14, 3.425, so 3.43 meters per second. I wrote that wrong, it's 3.43. Okay, that's all. That's all they want us to know. Okay, moving on. I think this is also the other repeated question. I'm actually not sure, but there are a lot of repeated questions in questions. Overall, in this quiz, there are a lot of repeated questions, and questions 30 and 31 are the ones I'll skip because I think I repeated them twice. So, at the moment of time when the particle is instantaneously at rest is 5 seconds. Okay, instantaneously at rest, when you have an xt graph, okay, means, again, it's a flat tangent, so like this. So when is it at rest? Here. This is when it's at rest. Okay, if it was a VT graph, the velocity would be 0. Okay, if you were to graph this, yani. But here, it's when the tangent is at a flat line, which is at this point. When you go down, it's 5 seconds. Okay, at t equals 11 seconds. So at t equals 11 is here. This is 11 seconds. The distance, so they want us to find average speed and average velocity, I believe. Yes, instantaneous. Okay, as you can see, it's a straight line, approximately a straight line. Like you can graph it, it's almost a straight line. So that's why they said in the given, okay, that's why they said approximate, right? Because it's not exactly a straight line. You can see it's a curve, right? But if you take it at a short enough interval, yani here and, for example, here and here, okay, it's a straight line between the two, right? So you can take that as your interval. You can take this as your interval. And as you can see, it's a straight line between the two, almost a straight line. So that's why you can approximate with. Now, we're taking these 2 points, which is exactly what we're going to do. This is 4, I believe 4, 8, 6, 4, 8, 12, 16, 20. Yeah, this is 4. This is 0. So now, the velocity, okay, the velocity is going to be 0 minus 4, because it's final minus initial, okay, over 1 second, which is gonna give me, I don't think this is correct, is it? Oh, is it -4? It's -6. T equals 11. Wait, does this go up by 1? 1, 2, 3, 4, 5, it does. Okay, so this part is 4, pretty sure. 4, 8, 12, 16, 20. Yes, it does. This part is the origin. Sorry, this part is the x-axis is the origin. This is 11 seconds. Okay, so basically, why my answer was wrong? Well, technically, it's a complicated story, but as you can see here, this is off by a bit, right? This is 10 here. This would be 4 and 10, and at the same time, this would be 0 and 11, right? But they're off by a bit. As you can see, I'm drawing them. They're not there. However, this is because you're approximating here and they're approximating here, you're gonna get an answer that's off. But if you only approximate once, which is here, and then you get this point, which, as you can see, passes exactly, it is passing through this coordinate of time, which is 12 seconds, and this coordinate of I'm just gonna draw them very quickly. Coordinate of position, which is -12 meters. Okay, this is passing exactly, so you're only approximating once, which gives you a more accurate answer. Doing this, okay, approximating this, taking it to be 0,11, okay, it's gonna be 12, or sorry, this is gonna be 11,0. 11,0. It's gonna be 12 minus 11 on the time, so it's gonna be 12 minus 11 over how did I zoom out? Okay, whatever. It's gonna be over negative 12 minus 0. So negative 12 minus 0, which gives me, so this is gonna be 13. No, wait, 1 second. 11's here. Okay, this is 11, 12. This is 12. Okay, and this is negative 2, negative 4, negative 6. Negative, oh wait, what? No. Negative 4, negative 8, negative 12. Okay, so I just found it. How did I, where did it come from now? Anyway, so this is gonna be 0 here, 0 here, 1 sec. Okay, yes, that's why I was getting confused. This is not 12. This is 13. 13 seconds. 13, and if you trace it all the way, it would give you negative 12. So the velocity is gonna be 13 minus 11 over 12 minus 0, which gives me 12 over 2, or sorry, this is gonna be negative 12. Negative 12 minus 0, which is gonna give me negative 6 meters per second. Okay, now, why didn't this work? Because as you can see, as I said, the average velocity equals the instantaneous velocity only when it's a straight line. Okay, only when it's a straight line. Now here it's still curving a bit. As you can see, it's still curving, right? But here it goes as a straight line. So this would be a more accurate approximation. Okay, and because here again, look, it doesn't exactly reach for 10,4. It's off by a bit. It's like 4. It's like 10.1, 10 point something like that. Okay, comma 4. Right? Same thing with this. It doesn't exactly reach the origin at 11 seconds. So you're approximating here and you're approximating here, which leads you to an off answer. But here, this is an exact point. It is passing through 13 seconds and negative 12 meters. Right? So you're only approximating once, which gives you a more precise answer. Anyway, so we found the approximate instantaneous velocity. Now, remember, the magnitude of the instantaneous velocity is equal to the average speed. So it's going to be 6 meters, as we said, because the magnitude of the instantaneous velocity is just 6 meters per second, which means that the instantaneous speed is going to be 6 meters per second. In a 3 kilometers run, Sam covered the first 1.5 kilometers at the speed of 0.6 kilometers an hour and the second 1.5 at the speed of 0.8 kilometers an hour. The average speed. Okay, so we're going to find the total time. Okay, the total time, so t is equal to the total time is going to equal to, now, if the formula is average speed equals distance over time, then multiply this and then take it as down. It's going to give you, like, rearranging the formula, okay, t is going to equal to the distance over the average speed, right? So what's the distance here? 1.5 kilometers, and the average speed 0.6 over the first interval, plus then the second interval is 1.5 over 0.8. Okay, I'm just taking them into these two intervals, as they told me to. Okay, now, 1.5 over 0.6 plus 1.5 over 0.8 gives me 4.375 hours. Okay, it's a very long time to run 3 kilometers. This guy's very slow. Now, the formula is average speed is distance over time, right? They want the average speed. We have the total time it took, and we have the distance, which is 3 kilometers, right? So it's going to be 3 over 4.375, which is going to give me 3 over 4.375. 0.685, we're down to 0.7 kilometers an hour. Okay, question 23. A motorbike rider moves along a straight road due north for what should be a 300 kilometers trip. She covers the first 100 kilometers in 50 minutes and then backtracks 50 kilometers in 20 minutes to see a friend. After seeing her friend, she covers her journey to finish in 170 minutes. Okay, now, here, the total distance covered by the rider, okay, it is going to be 300 plus, or sorry, not 300, it's going to be 110, because she covered the first 110, and then 50, right, because she backtracks 50 kilometers, and then 300 minus the sum of these two. Okay, this gives me 110 plus 50 plus 300 minus 110 plus 50. It gives me, oh wait, this is wrong. This doesn't make sense. Wait. Okay, so here, what I did wrong is the first two parts are correct. That's 110, that's fine. 50 is fine, right? But بعدين how much is the rest? So then she covers, so how much does she cover now? She covers, so she's at 60 kilometers, right? Because she was at 110, then she backtracked 50, so she's at 60 kilometers now. She finishes her journey, so she reaches 300 kilometers. What's the difference between the two? 240. So plus 240, this is the part that's wrong. 110 plus 50 plus 240, 400. That's the answer, 400 kilometers. Now, what's the displacement? The displacement is always going to be the final minus the initial. The initial was 0, the final was 300, okay? Because she finished her journey, right? And the journey was 300 kilometers, okay? And then it says the road is due north, right? 300 kilometers to the north. What's the average velocity? It's 300 over, because remember, it's displacement over time. 50 minutes plus 20 minutes plus 170 minutes. So 50 minutes plus 20 minutes plus 170 minutes. This gives me 240 minutes, right? But I want to change it to hours, because remember, it's 75 kilometers per hour. All my options are kilometers an hour. So divide this answer by 60 to give me 4 hours. Now 300 divided by 4 will give me 75. And that's the answer. 75 kilometers an hour to the north. Question 24. This is very easy. Velocity of the truck A. Remember, the velocity is the average. The average velocity equals to the instantaneous velocity on a straight line. So we can take this point here, and we can take this point here. Now, so 1 minus 0 is just going to be 1. 3 minus 2 is going to be 1. So the average velocity is 1 meters per second. Right? I took 1 minus 0, and then 3 minus 2. Which is going to be 1 minus 0 is 1, 3 minus 2 is 1, 1 over 1 is 1. So 1 meters per second. Velocity of truck B. Velocity of truck B, I can take the intersection point again. And here. So now, 1 minus 0 is 1. Okay, 3 minus 1 is 2. So 2 over 1, 2 meters per second. Now, meeting time. So you look at T when they meet. It's going to be 1 second. That's their meeting time. Okay, the meeting position, you look at the x-axis, or you look at the y-axis, which in this case is x in terms of m, which is 3 meters. Right? Now, moving on, question 25. Okay, so first of all, they want you to know when the car is at rest. The car is at rest when the slope of the tangent is flat, which is at this point here approximately 0.5 seconds. Okay, between 0.5 seconds and 2 seconds, the velocity of the remote control car is negative. Yes, because 0.5 and then 2, you can see it's going down. It's going towards the origin, right? It was above the origin, okay? So say the origin's here, right? And then it's going towards the origin, okay? So that means it's moving in the negative direction, because remember, it's one-dimensional. Right, this is one-dimensional motion, right? So the origin's here. It was here. The car was here at 0.5 seconds, but then it started moving back. Okay, so that's why the velocity is negative, and then the average velocity, you just find it by doing this point minus. We can take any other point, can't we? Yes, we'll take this one. So I don't recommend taking it. We'll take this point and the peak. Why not? Okay, how much does this go by? 1, 2, 3, 4, 5. So minus 0.5 goes by 0.1. So 0.6, 0.7, 0.8, 0.91. Okay, so this is 2.1, right? 2.1 and 2. 2.1 and 0. So it's going to be 0 minus 2.1, which is going to be negative 2.1 over 2 seconds, right? Or sorry, over 1.5 seconds. Because remember, it's 2 minus 2, let me just do it. 2 minus 0.5. Okay, this gives me negative 2.1 over 1.5. Negative 1.5. Okay, this is starting to annoy me because this is not a straight line. I wouldn't take. I don't know why I took this point. This is like, as you can see, it's on the point on the curve. It doesn't belong to it. So a point on the straight line would be this point. The initial point I was gonna take anyway. So let's do it one by one. So 2 minus 1.5. Okay, that's for my time, and then 0 minus, where is this? 0.6, 0.7, 0.7. Okay, I believe at least 0.6, 0.7. Yes, okay. So 0 minus 0.7 over 2 minus 1.5, negative 1.4. Is the answer negative 1.4? No, 0.25. Oh, throughout the motion. Never mind, I was reading wrong. Okay, so here I thought they wanted this interval. No, throughout the motion means from the start till the end. I don't know why I didn't read. I should have scrolled down. So 2 minus 0, that's for my time, and 0 minus 0.5. Okay, this is going to be negative 0.5 over 2, which, as you know, is half of negative 0.5, which is negative 0.25 meters per second. Yeah, next time I should read. Question 26. A particle P starts moving from the origin at t equals t0 along a straight line. Then at t1, 3 seconds, the particle is at 9 meters, at t2, 8 seconds, the particle is at negative 3 meters, and t3, 12 seconds, the particle is at 12 meters. The average speed between t0 and t3. Okay, so t0 equals 0 seconds, and the initial position is at the origin, so 0 meters, come on. Now, t3 is 12 seconds, okay, x3 is 12 meters, right? So, it's going to be t2 minus t1 at the bottom. t2 minus t1 is 12 minus 0, it's just 12. X2 minus x1, so 12 minus 0, just 12. 12 over 12 is 1 meter per second. That's the answer. Okay, wait, 1 second. Yes, that's the average velocity. That's the average velocity for this part. Okay, now the speed, what I found was part B. I don't know why I found part B first. The speed is distance over time, right? So, by the way, the reason I'm confused is I just woke up. It's 9 o'clock in the morning. Now, distance is, where is the distance? My distance is here. So it starts off from the origin. Let's draw it on a straight line. So the origin's here. Okay, or actually let's take the origin to be right at the start. So, origin, okay, then this is x1. This is x2. Okay. Sorry, let me do it. Negative 3 here. This is x2, and then this is x3. Okay, so it moved from x0 to x1, which is 9 meters, plus 9 to negative 3 is a 12 meter difference, as you know, because 9 minus 3 is 9 plus 3, which if you add it is 12. Now, negative 3 till 12 is going to be 15 meters, right? Because remember, you just apply the formula I taught you. The distance is the absolute value of the final minus the initial. Okay, now keep aware of the signs, right? Because if it's minus, say for example, distance is equal to absolute value of final minus initial. If your initial was negative 3, it's going to be distance is equal to the absolute value of final minus negative 3, right? So these two become a positive. Okay, now add all of these up together. 9 plus 12 plus 15, it's going to be 36. The time, as we said, is 12 seconds. So 36 over 12 is 3 meters per second. That's my final answer. Question 27. A cyclist is traveling along a straight line OAB and then back to A. The coordinates, okay, blah, blah, blah. The segment of journey, okay. So this is all useless given to me. All I care about is this part. OA, the displacement is 20 meters, as you know. This is very easy. And the distance is 20 meters. Again, displacement and distance are in the same direction or are equal since the motion's in one direction, right? Again, when the motion is in one direction like this, the displacement is equal to the distance. Now, BA is going from B to A. Okay, so like this. The distance is 80. Okay, that's easy because that's 100 minus 20. But how is the displacement negative 80? Right, listen. What is the same? Let me clarify my statement. When I say here in one dimension, the displacement is equal to the distance, I mean the magnitude. The magnitude of the displacement is the same thing as the distance, okay? Not the direction also. The direction is something else, as you know. So we can find it, right? Since it started off at 100 and ended at 20. 20 minus 100 is negative 80, and this indicates the direction. So it's negative 80 meters. Now, OA, BA. Now, since this is not in one direction, it goes from OA to AB, then back to this, right? The distance is gonna be not equal to the magnitude of the displacement, right? So let's find the distance first. O to A is 20, A to B is 100. So we have 120 so far. And then back to A, so then 80, right? So it's gonna be 180 because we added, remember, 20, 100, 180. Done. Okay, the displacement is just going to be whatever is in between of these two, O and A. O and A is 20, as you can see they're 20 meters apart, so the displacement is 20 meters. Okay, question 28. You have this table, and then they wanted to find the average velocity in a 20-second interval. Okay, so now 20 seconds is what's given. 60 minus 0. 60 over 20 is 3 meters per second, right? Because look, they mean throughout this 20-second interval, so from the start to the finish. So 20 minus 0, okay, and 60 minus 0 leaves you 60 over 20, which is 3 meters per second. Okay, now the average speed is something else. The average speed is gonna be 10 plus 20. So sorry, it's gonna be 10 plus negative 10 to 20 is 30. Then plus 20 to 60 is 40. So it's going to be 40 plus 40 is 80. Okay, 80 over the 20-second interval, so over 20. This is going to equal to 4 meters per second. Right, now, the highest average velocity, okay, you just have to find the slope between the two. So this is going to be 10, negative 10, okay. This is going to be 10, and this is going to be 40. Okay, so now this is 5, and then this is 5, and then this is 10, right? So 10 over 5, so this is negative 10 over 5 is negative 2, 10 over 5 is 2, and then 40 over 10 is 4. So wait, this is wrong. 1 second. How did I do this last time? I did this at night, so I was more focused. Okay, so this is negative 10, right? This is 30, then this is 40. Okay, so now this is 5, and then this is 10, right? So we're going to compare these values now, not what I did earlier. So negative 10 over 5 is negative 2, and 30 over 5 is 6, 40 over 10 is 4, right? So what interval had the greatest ratio of the two, which is this part here, the negative 2, the 6, and the 4? It's going to be wherever I had this. So I'm going to circle it. I'm going to put a square around it, actually. I'm going to erase everything else just to see where it is. You can see from my square, it's between the interval of 5 seconds and 10 seconds. Okay, question 29, which is the last question because the other two questions are repeated. A sports car moving at a constant speed of 20 meters per second passes by a stationary police car. Okay, after 10 seconds, the police car follows the sports car at a constant speed v. The police car catches up with the sports car in 60 seconds. Okay. Now, this isn't hard. Okay, this isn't that bad at all. What you do here, okay, is first of all, you remember the equations in URM. This is about URM. URM is v equals ut plus x0. So I show ut here. U is initial velocity. It's gonna be this x equals vt plus x0. This is URM. Okay. Now, so what is t? What is x? What is x0? This is the position. This is initial position. Okay, and then this is velocity, and then this is time. You should all know this. Okay, so first of all, you let the time. Okay, so let t equals to the time since the sports car passes the police, right? So that means, okay, at t equals 0, okay, the sports car and the police pass by each other. So the sports car passes by the police. Okay, so now at t equals 10, right? Because then at t equals 10, the police car reaches the velocity v, reaches the speed v, okay, and then stays constant. And then at t equals 70, right? Because look, it catches up with the sports car in 60 seconds, and it started moving at t equals 10. It's 10 plus 60, 70. T equals 70. The police car and the sports car are equal again. Okay, so the sports car, the equation of its motion is just going to be 20, since it's 20 meters per second, multiplied by t, right? Because it's vt, plus x0. Remember, x0 is relative to the time. This is dependent on this, right? The initial time, right? So when t equals 0, x0 is equal to 0 too, because that's when these two started passing by each other. That's when I started recording its motion, right? So it's going to be 20t plus 0. Okay, and then this is the equation of the sports car. The equation of the police car, it's gonna be v into t plus 10, because remember, it started moving 10 seconds later, right? So that's the equation of this car's motion. Okay, and now you set them equal to each other at t equals 70. So at t equals 70, 20t equals 2, or sorry, 20 times 70 equals 2 v into t plus 10. Right? You do this on a calculator. So 20 times 70 is 1400. 1400 is equal to x into t plus 10, or 70 plus 10, which is 80, equal. So on the second, I did something. Okay, it's sorry, not t plus 10. It's t minus 10. T minus 10, because it can't be t plus 10. So this is going to be v of t minus 10. Okay, so this is actually going to be 70 minus 10, which is 60. V is going to give you 23 meters per second. That's your final answer for part B. Now, you can use 23 and substitute it in to any of the two equations. We'll use the first one, v equals 20t. Okay, v is equal to 20 times 23, which gives me, or wait, I found it. I found both of them in the same part. Remember when I got 20 times 70? Right, 20 times 70 is 1400 meters. But 1400 meters can be changed to 1.4 kilometers. And that's your answer for part A, and I found part B in the process. So this is the end of this quiz. I hope you understood, or I hope you have a good rest of your day. Good luck studying.